Hello, and welcome once again to Friday STEAM. My name is Sandy Roberts, and I'm the Makerspace Coordinator for the Warren County Library System. And every week on Fridays, I bring you a project that takes science, science, technology, engineering, art, and math, and brings it all together so that you can learn something new. Today, our topic is a CD spectrometer. Now, you may not know what that is. We're actually technically making a very simple version of a very complex instrument often used by astronomers. They use this to actually get a sense of how warm a star is, what elements are inside that star. So they're able to use a spectrometer and look out at the stars and actually find out a lot about those stars just by the light that they emit. Because spectro is all about spectra, okay, and we're going to be looking at spectra of light today. As we go through, I am paying attention on my cell phone, so if you have any questions, you feel free to ask, and I will do my very best to answer them, okay? Keep in mind that all of our STEM programs and everything else is available on our website at warrenlib.org. You can also share any creations you make at hashtag WarrenLib, and we love it when you do that, especially if you go ahead and make a spectrometer today. So make sure you check that out because all of our summer reading programs are coming online, and we have got so many things planned. I am going to be doing lots of programs. We're going to have Maker Camp. We've got Friday STEAM continuing, Maker Monday, some coding, TREPs for entrepreneurship, all kinds of fun things, tons of great story times, adult crafts, and lots of special guests that we're going to be hosting. So make sure that you check out that website. All right, I'm hoping everybody's here. Let's get started with today's project. This is ultimately what we're going to be building, and it's a pretty simple device. You just are going to be looking in here, and we're going to break up light and get to see how it works. Now, that may not make sense to you, so it's not a very sturdy device. It falls over. Let me show you what I mean. Oh, that is not the right website, Sandy. That's the right one. Okay, so the electromagnetic spectrum. Basically, there are a lot of waves constantly traveling around us. Radio waves, of course, you might use in the car. Microwaves we use to heat our food. Infrared is what we use for our television remotes. But the visible spectrum is the one that we're talking about today. And here you can see this rainbow of colors, okay? All of our light looks white, but in reality, there's actually a whole lot of different colors together in light. So white light is actually all the colors of the rainbow shining at once. Now, why do we see different colors? Well, when that light shines on different things, some of the light is absorbed and some is reflected. So it's either absorbed by that or bounces off. When it bounces off, the light that isn't absorbed travels to our eye. When it reaches our eye can understand that wavelength of light as a color. So the truth is, if you're wearing a blue shirt, it absorbs every color except blue. Blue is what gets bounced off of the shirt into your eye, which is pretty crazy if you think about it. And the reason that we have really cool rainbows is because water does a really good job of refracting, breaking up light. And you can see this sometimes if you're spraying a mist through your hose, or even if you have a cup of water and you shine the light on it just the right way, you'll see that water can break up light. Okay, let us see if my little demonstration will work today. I'm going to hope. Okay, I have blocked a lot of light from my document camera area today, and we're going to see if my flashlight is going to come on. Apparently it's not. Let me try this again. There we go. Can you see that? Yeah. So what I have here are prisms. Okay, prisms are little pieces of plastic or glass that can actually refract or break up light. So let's see if I can get a rainbow, if you guys can see the rainbow. I might need to get a piece of white paper for you to be able to see my rainbows well. I was playing with this before. I had it. It's not coming out so good. 1 second. Where's my box? Dun-dun-dun. Okay. Let's see if we can get our rainbow. I'm just shining the light of... Oh, there we go. Now you can see it's breaking up. There it is. See that rainbow? Okay. I've got that light broken by the prism into all of the different colors. These are really fun to play with. They're pretty inexpensive to buy, and you can find them in a lot of different places. Light doesn't only refract or break apart. It can also be, here we go, reflected, like with this mirror. So I can bounce this light all over the place with the mirror. And that's why when you look at a mirror, the light is bouncing back your light. Like literally the light bouncing off of you is bouncing off of the mirror and coming back into your eye, and that's why you can see yourself, which is kind of weird when you think about it. So we have refraction, we have reflection, and then we can also condense light, okay? We can condense the light, and when we do that, let's see, can we... Doing that is the principle of how a telescope or a microscope works, because you have to condense the light if it's something far, far away to be able to see it. Think about that. If it was really shady, it would just be kind of a blur. But if we use lenses to condense the light from the stars, we're able to see it. So this idea of refracting or reflecting light is really, really important. I just dropped my glasses. Hopefully I won't step on them. You can also bend light, which is pretty cool too, okay? And that's going to have to be a topic for maybe another day. All right, coming on back here. Where am I? Where'd Sandy go? Okay, I'm back. Now I've got my big box. I'm just going to move the big box for a moment because we're going to need this space to build our spectrometer. It's a Friday. It's been a long week. All right, so what are you going to need for this activity? Here we go. You're going to start off with a toilet paper tube or a paper towel tube. Now, if you don't have one of these, an oatmeal box will work. Any kind of tall box will actually work for this really well. You just want something that's going to be tall because you want the light to be able to travel a bit of distance so that it refracts well. It breaks up well for our spectrometer. Toilet paper tube or a paper towel tube is pretty perfect, but like I said, wrapping paper tubes, oatmeal can, anything like that will totally work. You're going to need an old CD. And I'm just going to make sure I have my questions back up here, just in case. So you're going to need an old CD, like this one. We're interested in this side, so you want something that doesn't have a whole lot of scratches on it. An old DVD works. You could usually find these around. You're going to need a pair of scissors, okay? A good sharp pair of scissors, or get your parents' help. You might also have one of these. This is called a Canary Cutter. And they're a little serrated blade, but they're safe, so they can help sometimes with cutting details. And then you may decide that you want a bit of tape. And if you want to be really careful, you may want a ruler, and a pencil. So that's all the supplies you need for this one. It's really simple. And as you can see, I didn't even tape mine in, and it works absolutely fine. All right, so let's go ahead and build this. I'm going to switch back to my document camera. Here we go. Got our supplies. We need our scissors. I'm just going to turn on the light here so you can see a little bit better. I turned it off for the other thing, but maybe make that a little bit easier. I need a better light. I say this every week, don't I? Every single week I'm like, I need to get a better light for my document camera. And yet every week I don't get a better light. What are you going to do? Tape, ruler, pencil, my tube, and my CD. All right, and you can even see, look at that. It's already refracting light. See how it's breaking up the light already? Just even hanging these, like paint this side, hang these outside, makes a really nice mobile. It's all shiny. Okay, so we want to do a quick bit of measurement. Ideally, we just want to create a slit on the back a couple inches up from the bottom. So I'm going to go 3 inches. I'm just going to mark my tube. And I'm doing 3 inches because I want something, yeah. So our CD, if you can see that, is about 5 inches across. So I want something that's a little bit more than halfway because we don't want our CD to pop out the bottom. Okay? So I've marked my 3 inches here. And you can eyeball this if you don't feel like measuring. I just like to measure it because I feel like it gives me a little bit better results. I'm also going to mark 3 inches on the other side because my viewing window, okay, my viewing window, I want to be lined up with where my CD is. So let me show you that on this one. Here's the slit for the CD, okay, and there's my viewing window. So I look in this part. So I want the top of my viewing window to be pretty well aligned with where my CD is. So that's why measurement is kind of useful for this. Okay, so I've got that marked, both sides. Make sure I've got it good. Now I'm just going to squeeze the tube a little bit here. Take my scissors and make a cut to about halfway across the tube. You want to go at about a 45-degree angle. Okay, so I like to think of that as like it's half of an L. Okay, so about 45 degrees. And if you have a protractor, you can certainly use it to make sure. As you can see, I cut halfway into my tube. Okay, great. I find that this can sometimes be a little bit of a challenge to getting my CD to sit right. So you could just fold down that little point a little bit. All right, now we're going to very carefully look to the other side. We've got our mark here. Okay, and we want to make sure that it's right across this. We want to make sure it's right across from where we put our viewing hole. So you can do a circle. I just cut a rectangle. I think it's just honestly a little bit easier. And you see I'm just kind of sketching a small hole. It does not need to be big. In fact, you don't want too big a hole because we don't want light to be getting in here. We want all of our light to be traveling down from the top of the tube. So again, I'm just going to carefully squeeze, right? Well, I didn't do a great job there, but that's part of why we have the masking tape, because if we need to, we can always use that to fix our mistakes. Okay, so I've got myself a little tube here, a little viewing window, and I'm going to, like I said, I'm just going to take a bit of masking tape. I'm going to seal up the little spots where I cut a little bit too much. I was a little overzealous today. Now, at this point, you may decide that you want to decorate your spectrometer, and I absolutely encourage that you do that. So you can get out some star stickers, you can get out some paint or construction paper, and really make it look super cool at this point, because this is a great chance to show how much you love science. Okay, so there we go. I cleaned that up just a little bit. Now I'm going to grab my CD, and again, make sure that it's clean. Make sure it doesn't have too many scratches. Mine has a couple scratches, but it's still reflecting very well. It's still refracting well. I'm just going to go ahead and insert my CD right on into that slit. And I'm going to take a quick look and see. I'm going to look through the hole and make sure, am I looking at my CD? Yes, I am. At this point, you may decide that you want to cut your slit a little bit deeper if you want to get your CD in there a bit more. You just want to remember that you don't want to end up looking at the hole in the center of the CD. I am actually going to go ahead and cut mine just a bit deeper. I want it a little bit, see, we only go halfway at first because it's easier to make this slit a little bit longer. It's very tough to make it shorter, okay? So there we go. I'm just going to make that just a touch, just a hair longer, maybe a 1/4 of an inch longer. All right, and then I'm going to go and fit my CD in there. Ooh. And for some reason, there we go. Okay, so now I've got that fitted in there pretty well. This is a good, and I've got, I see what happened. When I cut the second time, I created a little notch there. All right, so I've got that in, and now I'm just going to take a bit of tape, and this is totally optional. If you feel comfortable using hot glue, you may decide instead to use hot glue for this part. But a little bit of tape on the back here, just to make sure everything stays in place so it doesn't fall out like mine was before. And I meant to do that on my sample, and things just got a little bit crazy today and I forgot. This happens. Okay, so there we go. So you see, I just put a little tape so that I know that it won't fall out. And there we go. We've got our spectrometer. Pretty simple, right? Now let me show you how to use it. Okay, so now that you have your spectrometer, what are you going to do with it? Well, the first thing you're going to do is, if you're inside, you're going to hold this up to your eye so that your eye is right here with that viewing hole that you made, that viewing window. And you are going to look. You're going to have to find the rainbow. Mine is kind of down low, and it's going to depend on your angle. It's going to differ a little bit. But I see red, yellow, green, and a bit of purple, which means that's the colors of light that are filtering into my windows. You're going to find that incandescent light, those old-fashioned light bulbs, fluorescent light, halogen light, and sunlight will all have slightly different spectra because they're all made up of different amounts of different colors of light. So even though we see them all as basically white light, you may find that some of the lights in your house are a little bit more warm. They have more yellow or red, while others are more cool and they have more blues and greens and purples. So it's really exciting to find out which lights in your house work different ways. One of the simplest things you can do is just your cell phone, your light. If you have a flashlight on your cell phone, put that down and see what you get. When you go outside, you should find relatively equal bands of all the colors: red, orange, yellow, green, blue, and purple. Okay, so I want you to get outside and give that a shot. Report back to me and let me know if you find any lights that maybe are a little more warm or cold in your house. You can even, if you're really careful, sometimes you can put your cell phone here and take a picture of your rainbow, which is really fun to do. I hope that you had fun making your spectrometer. Why am I having trouble with that word today, guys? Spectrometer. I know this word. All right. So I hope you had fun at Friday STEAM today. I hope that you go out and make your project and enjoy it. I will be back next week again at 2 p.m. and I will see you on Monday at 2 p.m. for Maker Monday. We have a ton of great projects picked out for you this summer, and I am really looking forward to it. Just so that you know, when summer reading starts, June 15th, that week, Friday STEAM is going to get pushed back to 4 p.m. and will continue to be at 4 p.m. for the rest of the summer. That's just to make some space for some other amazing programs that we have, okay? So, as a reminder, my name is Sandy Roberts. I am your Makerspace Coordinator for the Warren County Library System. We absolutely miss you, and we cannot wait to see you again. But in the meantime, stay safe, stay healthy, and make something really amazing. All right, guys, take care. I'll see you soon.